Welcome back, everybody. This is going to be the final of two parts in my lecture series on graphing polynomials. If you haven't watched the first part, you're going to want to go back and watch it because that information is going to be really important for this one. In this video, we're going to actually sketch the graphs using the information we learned in the last video. Let's get started. And we're gonna start simple. Let's sketch the graph of f of x equals x to the fourth minus 9x squared. You may remember from the last video, I need this information. I need the end behavior, the y-intercepts, the roots, and their multiplicity. So, let's find that information in order. Number one, end behavior. Remember, this depends on the leading coefficient, which in this case is 1, and the degree, in this case, it's 4. So, let me plot a graph here. The leading coefficient is positive, which means the left end is going to point up. And the degree is even, which means the right end is going to match it. And I like to just sketch these arrows now, so that later all I have to do is connect the dots. Number two, y-intercepts. Remember, this happens when x is equal to 0. So, I need to find y when x is 0. Well, turns out it's just 0. So the point 0, 0 is on the graph. Step 3. I need to find the roots. Remember, these are the zeros or the x-intercepts. So I need to fully factor this guy and set it equal to 0. Notice both terms have a common factor of x squared, so I can pull that out, and I'm left with x squared minus 9. That x squared minus 9 term, though, can be factored even further, because it's a difference of squares, into x plus 3 and x minus 3. So I know the roots are x equals 0, negative 3, and 3. And now I plot them all. I've already got 0. I need negative 3 and 3. Last step is the multiplicities. Notice my root for 0, I have 2 copies of. So this is multiplicity 2. Negative 3, I've got multiplicity 1, because I've only got 1x plus 3. And I've got 1x minus 3. Multiplicity 1. For odd multiplicities, we cross. For even multiplicities, we bounce. So let's start from the left side. I'm going to connect the dots here from my end behavior down to my root. And I know at negative 3, I've got an odd multiplicity. So I'm going to cross through the x-axis here. I've got a cross. Here, though, I've got a bounce. So what does that look like? I'm going to come up to the intercept and then bounce off of it and go back down. And then here I've got a cross. If you have found your multiplicities and your roots correctly, first of all, you should be able to connect the dots and make it line up with your end behavior. Second of all, you should only touch the x-axis in the places you have already labeled. So if you find yourself not lining up with your end behavior or crossing the x-axis where you didn't previously label it, chances are you made a mistake somewhere else. Let's try another one. This guy is already fully factored for us, which is nice. I would like you to pause the video here to see if you can try this one on your own. This is the answer that I found. First of all, I need to determine the end behavior, and you may be wondering how I found the leading coefficient in degree without first representing that in standard form. Now, if you would prefer to just FOIL everything out and write it all in standard form, that's fine. Please do so if that's what works for you. But it is a lot of unnecessary work because I know at the end of the day, the first terms in all of these are going to get multiplied together. So I'm going to have 3 x's, a fourth x, and a negative 3. So my leading term is going to look like negative 3x to the fourth. That has degree 4, and my head is in the way of that. Let me move it here. That has degree 4 and leading coefficient negative 3. Since the leading coefficient is negative, I know the left end points down, and the degree is even, so I know the right end matches. Next, I find the y-intercept, which I found to be at 64. Then I find the roots, which I can read right off of this guy since it's already fully factored for us to be negative 1/3 and 4. And finally, I need to find the multiplicities. I only have 1 copy of x plus 1/3, so it's 1. And I have 3 copies of x minus 4, so it's 3. That tells me at this root I cross, and at this root I cross. And you may be wondering at this point, so what happens in between? The answer is, without going to Calc 1, we don't know what's happening in between exactly. And even with that information, it can be awfully difficult to tell. So, for example, this is how I chose to connect the dots, but let's flip over to a graphing utility. What it really looks like. As you can see, I got some of the details wrong. For instance, it goes a lot higher up beyond the y-intercept, right? It comes all the way up here to 111 and some change before falling way back down. And it's also got almost this kind of S shape, almost like a cubic over here at 4,0. But I couldn't possibly know that information without a graphing utility or without Calculus 1. So I don't expect you to replicate that on your graphs. Really what I'm looking for is those important points, the roots and the intercepts, and I want to see the multiplicities and the correct end behavior being respected there. That's really all the detail I'm looking for. In this video, we took a look at how to sketch the graphs of higher degree polynomials. That's going to wrap it up for this lecture series. Catch y'all in the next one.